In this example, we are asked to determine the Z parameter for the network shown below, and the network is a T network. And to solve this, we have to calculate our Z parameter in pairs, and we'll first of all calculate our Z11 and Z21, because at Z11 and Z21, our height 2 is set to be equals to 0. That is, there's an open circuit at the output side, and so by setting our I2 to be equals to 0, we have an open circuit at the output side, and our Z11 is V1 over I1, and our Z21 also is V2 over I1, as we'll see in the next slide. From the diagram given, we will redraw it to calculate our Z11 and Z21 by setting our I2 to be equals to 0, that is open circuit at the output side of the two-port network diagram given, and our V1, that is a voltage source, input voltage source, will place it at our input side, and that's V1 as we can see, and our formula Z11 equals to V1 over I1. Voltage is calculated from Ohm's law, which is I multiplied by R. The R in this diagram, the effective resistance in this diagram is 20 is in series with 40 ohms, that is 20 plus 40 ohms multiplied by our current I. Remember that the 30 ohm is no longer valid, is not working, is not functioning, is not effective, because the other leg is disconnected from the circuit, and that's why 30 ohm is not used. So our Z11 will be 60 I1 over I1, that gives us 60 ohms. Our Z21, the formula for Z21 is V2 over I1, and our V2 is the voltage across the 40 ohm resistor. We can calculate the voltage across this 40 ohm resistor by multiplying it with the current flowing in the circuit, and the current flowing is our I1. That's why we have our 40 I1 for our V2 over I1. That gives us also 40 ohm. Similarly, to calculate our Z12 and Z22, we set our I1 to be equals to 0, that is open circuit is placed at the input side by redrawing the diagram, and also our output voltage V2 is placed at the output side, and then our I1 is equals to 0, but V1 is at the input, the voltage at the input. So our formula for Z12 is V1 over I2, and our V1 is the voltage across the 40 ohm resistor. Remember, in this case, the 20 ohm is no longer functioning because the second leg of the resistor is disconnected from the circuit, so it's not effective, it's not functioning, it's not contributing to the circuit. So V1 is the voltage across the 40 ohm resistor, and the current flowing in the circuit is I2. The current is flowing in 30 ohm and 40 ohm. Remember, the same current is flowing through resistors in series. So our V1 is 40 multiplied by I2, and our I2 remains. So Z12 will be 40 ohms. Our Z22 is V2 over I2. V2 is the total is the voltage drop in the circuit, and the voltage drop across the 40 ohm and the 30 ohm resistor is 70 I2. So our Z22 will be 70 ohm. To put it in matrix form, we have 60 ohm, 40 ohm, 40 and 70 ohm. We are asked to find the Z parameter for the pi network shown on this slide. The first thing we'll do is to calculate the Z11 and Z21, and to calculate that, our I2 must be equals to 0, even though it's not the diagram was not shown, but we, just like the previous example that we did, we place I2 to be equals to 0, that is open circuit at the output side of the network given, and then our V1, the voltage input source V1, will be placed at our input side. Doing this, we will see that our 5 ohms and 15 ohm resistor, they are in series. Both of them are in parallel with 20 ohm resistor. So our Z11 formula is V1 over I1, and our V1 from there will be equals to our 20 in parallel with 20 ohm resistor multiplied by our I1, and 20 in parallel with 20 ohm resistor will give us 10 ohms. So V1 will be 10 I1 divided by I1, and that will give us 10 ohms. So from there also we can calculate our V2. Remember, our V2 is the voltage across the 15 ohm resistor. Remember, 15 ohms resistor and 5 ohm resistor, they are in series. So V2 using voltage divider principle will be 15 over 15 plus 5, that's 20, multiplied by the total voltage, which is V1 in the circuit. And so that will give us V2 to be equals to our 0.75 V1. We remember we already calculated our V1 to be 10 I1. So 0.75 multiplied by our 10 I1, that will give us V2 to be 7.5 I1. So Z21 will be equals to V2 over I1, and our V2 is 7.5 I1 over I1, and that will give us 7.5 ohms. Or just use our V2, which we already calculated, to be 0.75 V1, and our I1 from Ohm's law, I equals to V over R. That will give us V1 over 10. That will equally give us 7.5 ohms. So calculating for Z12 and Z22 now, we'll set our I1 to be equals to 0, and our formula for Z22 is V2 over I1. Remember, since our I1 is equals to 0, that is, there is an open circuit at the input side now, and then our voltage source V2 will be connected to the output side of the circuit. So our V2 from the diagram will be equals to our 15 ohm resistor. Now our 15 ohm resistor will be in parallel with 20 and 5 ohm in series. That is, our V2 will be 15 in parallel with 25 ohm resistor, and 15 in parallel with 25 ohm resistor will give us 9.375. So V2 will be 9.375 I2 divided by our I2, and that will give us 9.375 ohms. From there also we can see that our V1 is the voltage drop across the 20 ohm resistor, and remember, the 20 ohm resistor is in series with 5 ohm resistor now. So using the voltage divider principle, our V1 will be 20 over 20 plus 5, that's 25, multiplied by the total voltage in the circuit, which is V2. That is, we have our 20 over 25 multiplied by our V2. We already calculated our V2 to be 9.375. So 20 over 25 multiplied by 9.375 I2. That will give us 7.5 I2. So V1 will be 7.5 I2 divided by I2, and that will lead to our Z12 to be V1 over I2, and that will be 7.5 ohms. Or simply put, we use our I2 to be equals to V2 over 9.375. Remember, our V2 is already 9.375 I2, and then we substitute for I2 in the formula Z12 equals to V1 over I2. That will equally yield 7.5 ohms. We are asked to find I1 and I2 in the circuit given here. and our impedance parameters are given. Z11 to be 40 ohms, Z12 to be J20 ohms, and Z21 to be J30 ohms, and Z22 to be 50 ohms. From this circuit, we can see our V1 is definitely 100 angle 0 degree volt, and our V2 will be minus 10 I2, that is the voltage drop across the 10 ohm resistor. Substituting this into our impedance equation. Remember our impedance equation: V1 equals to Z11 I1 plus Z12 I2, and V2 equals to Z21 I1 plus Z22 I2. We substitute this value into that. We have our 100 angle 0 ohms, as we will see later in the next slide, to be equals to 40 I1 plus J20 I2, and our V2, which will be minus 10 I2, to be equals to J30 I1 plus 50 I2. Our V1 is 100 angle 0 degree, and V2 is minus 10 I2, and we already know our Z11, Z12, Z21, Z22. Putting all this into the general impedance equation, we'll get the two equations on this slide, and that will lead us to get our I1 to be J2 I2. Getting our I1, we can substitute it into the first equation, that is into the equation 100 plus 40 I1 plus J20 I2. When we substitute our I1 into that equation, we'll get 100 equals to J100 I2, and our I2 will be J100 divided by 100, and that will be J, as we'll see on the next slide. Our V1 is equal to 100 angle 0 degree, and V2 equals to minus 10 I2. Substituting this value and the value of our Z11, Z12, Z21, and Z22 that is already given, that we already know from the question. Substituting these values into the general impedance equation, we will have 100 equals to 40 I1 plus J20 I2, and minus 10 I2 equals to J30 I1 plus 50 I2. That will then equally lead us into getting our I1 to be equals to J2 I2. From the second equation, we'll get our I1 to be equals to J2 I2. Now if we substitute the value of our I1 into the first equation, into the equation 100 equals to 40 I1 plus J20 I2, we will get 100 equals to J100 I2. Then our I2 can be equals to 100 divided by J100, and that will give us 1 over J, which will later be equals to minus J on the next slide, as we'll see. Then we'll get our I2 to be equals to minus J, and from there we can calculate for our I1, and our I1 was initially J2 I2, and so substituting for the value of our I2 into that equation, we'll get our I1 to be equals to 2. So I1 will be 2 angle 0 degree amps, and our I2 will be equals to 1 angle 90 minus 90 amps. In this example, we are asked to find I1, I2, V1, V2 in the circuit on this slide, given the matrix of the impedance parameter. So from the matrix given, we can see that our Z11 is 10, our Z12 is minus 6, and our Z21 is minus 4, and our Z22 is 12 ohms. So in this circuit given, we will need a voltage, we will need source transformation, since 3 amps and the 4 ohm resistor, they are in parallel. We transform from the current source to the voltage source, and to do that, simply using V equals to IR, we can see our voltage will be 12 ohms, 12 volts, sorry, 12 volts, and 12 volts will be in series with a 4 ohm resistor connected also in series with 2 ohm resistor. Then it will join our two-port network, as we will see on the next slide. So using the source transformation, here is the circuit that we will get, and from this same circuit also we can see our V1 using the KVL, that is Kirchhoff's voltage law. The voltage across the loop on my left hand side will be 12 equals to 6I1, that is 4 plus 2 will give us 6I1 plus V1, and that would definitely give us our V1 to be 12 minus 6I1, and our V2 also will be minus 10I2, that is the voltage drop across the 10 ohm resistors will be minus 10I2, because the I2 supposed to be flowing out, so it's flowing in opposition to the current I1, so that's why it's minus 10I1. So getting all this, our general formula for the impedance equation is V1 equals to Z11I1 plus Z12I2, and V2 equals to Z21I1 plus Z22I2. We'll put all these value into this equation, and we'll have our V1 to be 12 minus 6I1. Our Z11 has already been given in the matrix to be 10I1, then plus our Z12 is minus 6I2, then our V2 is calculated to be minus 10I2. Our Z21 is given in the matrix, and that's minus 4. That will be minus 4I1, plus our Z22 will be 12I2, as we will see on the next slide. Putting the values of our Z11, Z12, Z22, and Z21 into the impedance equation, and our V1 and V2 into that equation, we'll have two different equation called equation 1 and 2, and if we solve this equation either by substitution or by simultaneous equation, we'll get our I1 to be 0.8049 amps, and our I2 to be 0.14634 amps. Then we can then substitute this value into our V1 equals to 12 minus 6 multiplied by our I1, and our I1 is already 0.8049, and our V1 will definitely give us 7.1706 volts, and our V2 also, which was minus 10I2, is minus 10 multiplied by the value of our I2, and that will give us minus 1.4634 volts.